Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about solar aircraft. So let's dive right into it. Well, first we have to understand this whole aspect that flying takes a lot of power. Basically, planes, no, it does not matter whether they are fighter jet, supersonic bombers, or just a fuel carrying aircraft. They take a lot of energy. So fundamentally, all of these they do not last. Fundamentally, they do not last. We want very long endurance. Now, speed is a certain requirement for certain jobs. You need speed, but here's the it's not be all of the situation. It's not like okay, only thing that matters is fast. For many other scenarios, you'll be like, I rather go slow, but I rather stay in the air for a very long time. For example, in 1990s and 1970s, during this period, a lot of research money from Soviet Union and USA were poured into making a nuclear powered aircraft just for one reason. They knew for flat out it will not be fast aircraft, but it will be very long endurance one. The idea was it could remain in air for a month or so. So endurance is also needed for certain kind of applications. Now, sun is always above cloud. Now, when you are talking about solar panels on ground, you always have to think about weather. But here's the deal: what if you are above the clouds? Then you're like, dude, I will get sunlight at this time. In basically, depending on altitude, depending on your location, you'll be like, okay, I'm gonna get sunlight from let's say 8 a.m. to let's say 7:30 p.m. Like you know for a fact, and it will happen every day in and day out. That gives you a reliable power source, like so your plane magically does not fall out of the sky. So that's the idea with this. Now, what is the logic behind it? Logic is solar cells, we use that's a real thing, common mass produced normal thing. But here's the it needs a lot of light. Everybody can think that. One thing you have to understand, because of our atmosphere has a gradient that even if you go few kilometers up, most of the atmosphere is below you. So even though our atmosphere technically stretches for 100 kilometers, it's not like that. It's not like perfect distribution. So you go 10 kilometer up, you lose 10%, you go 20, you lose 20%. It's more like you go 10 kilometer up, most of the atmosphere is down below. So once you go even as moderate as few kilometers up, you are in a position where you're getting a lot of sunlight, like serious amount of solar flux. Awesome. Another aspect, solar panels are kind of idiotic in the nature. They do not like to be hot. Now, if you live in India or you live in any equatorial place, you know for a fact that sunlight in mid-afternoon, while it's very bright and awesome, it's super hot. Solar panels here easily reach as high as 50 to 60 degrees Celsius. How the heck they're gonna do the rated power output when the power output on the back of the label, you can read that it's like rated at 25 degrees Celsius. Like what the hell? So fundamentally we need two things that are counter to each other. It's like get a lot of light but don't get too much heat. Thankfully, as you go up in altitude, you reach a point where outside atmospheric temperature drops. So you could have a scenario where you are like minus 40 degree Fahrenheit, minus 20 degrees C or something like that. So you could literally be at almost freezing point. And given the fact that solar cells will absorb heat once they are actually starting to generate charge, they will reach an equilibrium temperature and they will be like, okay, cool, awesome, we're gonna give you maximum power, no problem. So it's high altitude has it all. So it has a lot of light, awesome. It is above cloud coverage, so you don't have to worry about a cloud and all this and all that. And especially if you go very high up, you don't even have to think about anything. At that point in time, your literally solar panel is behaving like a satellite solar panel. And low temperature also makes them last longer and provide max power for maximum period of time. So that's the logic behind it. That's why we want solar power at that altitude. Now let's understand UAV, aka unmanned aerial vehicle. Now Moore's law allowed UAVs to become quote unquote practical, because we had UAVs for a very long time, very long time, but it was not very practical. It was just like go and see. But now we can do so much more. Like think of it this way: if you talk to someone, anyone dealing with computer technology, it's like, dude, in 1 watt you have to take a 4K video. They're like, dude, what are you smoking, bruh? Right now our mobile phone is like, bro, I can take the video, I can do 4K 422 10-bit, and I'm gonna upload that at 5G. So again, Moore's law allows us to have things that we could not even imagine possible. For example, NASA built a solar aircraft, solar Helios. Now this puppy was expensive. Like if you look at the project cost, you're like, damn. But this was done in 1999. You can do this in your garage for a fraction of the cost right now. So Moore's law is a really critical advantage here. Now, a lot of civilian and military application. I am reasonably sure I don't have to explain what military application means. It just helps people to reach elevated heights. But civilian, it's kind of hard to understand what the hell is the use of civilian, like UAV in civilian realities. Think of it this way: disaster management require UAVs a lot. For example, let's say landslide happen on a big area, on a remote area. how the heck you gonna know which roads are still intact? How the heck you gonna know where you can have a footpath where you can actually walk people and like, okay, use this path to reach here? You don't know because landscape fundamentally changed. So you need drones, UAVs, and they are being used right now as we speak. If there is a disaster right now, I can guarantee you somebody is using a drone to collect all these data. And imagine worst case scenario, let's say there is a huge dam, like huge dam, and it goes boom, something bad happens, earthquake happens, something bad, it goes boom. The amount of area is gonna destroy. That area will not be something like, okay, stand up on a hill and see what is happening. You need very high. Now you're like, hey, don't we have satellites for that? Here's the problem with satellite: distance. The lowest you can have a satellite is around 200 kilometers. While that is good enough for our modern electronics and camera equipments to capture good result, but because of the orbital mechanics, they always have a window of opportunity. It's like a disaster happened here, shwing, you have literally 20 minutes. Best case scenario, you have 20 minutes of to capture all the data. But if you have geostationary, you're like, okay, I have constant scene at the site, so you're like, awesome, 24/7, I'm gonna focus on that. Yes, deal, because your distance is now 30,000 kilometer plus. You cannot focus on it too much. Why? Because angular resolution, it's physics based. You cannot bypass this with modern technology. It's physics. So that's why the drone is that perfect tool. It's like you deploy it where you need it, and then you collect the data, and it's very invaluable. Like, we don't think about it because there are other people whose job is like, okay, which power line broke, where we can read out the power line, where we can lay down emergency extension systems. All these things we do not think about it because people who are dealing with this, they are using it and they are doing a very good job, so we don't have to worry about it. So a lot of civilian use is there, and modern UAVs are awesomely practical. Basically, right now, if you have to be like, okay, do everything in 1 watt, just buy a cheap Android phone, remove every electronics, and just like, tada, done, go home. Ain't nobody got time for that. So fundamentally, a lot of power in communication and surveillance is good for disaster recovery, management, everything, all things of that. And communication is very important in a disaster area, specifically flooding related. People want to be in touch. They're not dead, they're not inside a crumbling building, but they need to be in touch, otherwise they will go cuckoo. So fundamentally, having ability, even a simple ability as just, hey, SMS, just like, this drone will fly on top of you, you're gonna receive a SMS. We send SMS to whoever, or this exact number, because let's say all this number will be streamed to that point. It's like, okay, I'm here, I'm alive, everything is good, I don't have food or I don't have water, like, I'm here, I'm okay, come to rescue it, whatever have you. So communication is priceless at those kind of times. So UAVs are not just like boom, they are actually useful. Now, what about manned? Let's say you want to be a bit more adventurous. You're like, I want to fly. Thankfully, it can be done. And single-seater around the world trip has already been accomplished. That's thinking. There is a dude who sat inside a plane that was completely solar powered and that flew around the world. That's thinking. Around the world. Now, it was not a continuous flight. The reason for that, not because the plane could not do it, simply because the person inside it would be a very idiotically uncomfortable. And this was single-seater. If it had 2-seaters or 3-seater, then it might have been potentially possible. But again, the Solar Impulse 2, they did it just to prove a point that electric aircraft can be done. Electric solar aircraft can be done. So fundamentally, this was more of a PR system. This was more of like for guts and glory kind of scenario, but it was awesome. Amazing things. The amount of technology. This plane is very light, but the size, the wingspan is huge. Now you're like, okay, this is a bit more extreme, but what about like, down to earth? You have 2-seater where you can have 1 pilot and 1 passenger, and actual long range flight. Now, when I say long range, I do not mean like, a continent crossing. I'm like, quote unquote long range, 100 to 500 miles kind of scenario. Sunseeker Duo can be utilized for that. And this puppy is more of a hybrid between a glider and a low power aircraft. The benefit of that, it has a window that opens up. Like, you can safely open a whole window and just look out the window. And because of electric propulsion, it does not make a sound, and you can cut the engine. So if you want to like people want to study wildlife, they want to do a very close pass, but they do not want to scare the herd, so to say, they can just like, no problem, don't think about it, it's just got this. So there's a lot of use there, but be very mindful. These things are very slow because while they are getting a lot of solar power is not that dense. It's not like compared to jet fuel. So fundamentally, their acceleration rate is very slow. Their cruising speed is very, very slow. They can barely do 100 to 200 kmph. Now I'll be like, that's not too slow, given the fact that most time your car ride is much slower than that. But reality is, commercial jet system, that puppy runs at around 600 plus. So this is not, that's why the plane was that big of an issue. Otherwise, fundamentally, this aircraft physically can do 24/7 into 365 as long as it takes to, like, circle the world. But problem is, the person inside will go mad. So That is why they had a lot of hops. They're like, land in Hawaii, land in Japan, land here, land in Dubai. That was done just for the sanity of the basically pilot. So manned can be done. And I really like the idea of this system. If it does not have the power, don't try to sell it in power, try to sell it the low power attitude. And it's like, if you want to do sightseeing without disturbing the site, this is the perfect vehicle for it. So there's some potential, not too much. However, you have to understand this. When I'm talking about this technology, it may sound far out, it may sound not clear, or once in a while kind of scenario, but use of this puppy is serious. It's no laughing matter. It's so serious that Boeing, Airbus, defense contractors, and Facebook are pouring their money into it. So this is as serious as this is gonna get. So you have to understand it. High altitude allow it to do what we call pseudo-satellite. You will hear this word. Boeing is working on pseudo-satellite. Facebook is working on pseudo-satellite. So what the hell that means? In this context, it means a solar drone providing satellite function. So basically, it's going to be a solar drone. It's going to go very high altitude, as in higher than commercial airlines. It's going to be like high up, YOLO high up. Benefit of that, this is a plane. It's not a drone. It cannot remain stationary. But if it goes high enough and it maintains a circular path, it's like, high enough, no weather distortions and something like that will happen. So you'll be like, okay, I'm above weather. I got complete clear line of sight to sun. So complete solar power. And you're doing a circular path. Every ground station below you will literally think you are at a satellite, because it's like, I don't have to move my satellite dish like this. Like, okay, you are here, you are inside the cone of communication. So fundamentally, this allows pseudo satellite capabilities. What can you do? Everything a satellite can do, including much higher resolution weather analysis than any satellite feasible, simply because satellites cannot go that low. Because if you want to understand the weather, you have to be in the weather. So fundamentally, satellites cannot do that. Geostationary can give you a bigger picture. Awesome. It's like, this big cloud is happening from here. Awesome. But yes, do you know the relative data points on that point? No. You have to go get that data from a weather station on the ground or a lower Earth satellites. That's not gonna give you too much data. This puppy, it can literally fly on top of a hurricane and be like, okay, this is the exact detail of the hurricane. So you can understand this. This is very valuable asset. Search and rescue for long duration. That's why I specified, like, many disasters are slow burning disasters. Like, it's gonna take time, take 1 week, 2 weeks. In those sorts of scenarios, no drone is gonna last. Drones barely last 20 to 30 minutes in air, and even winged drones will barely last 2-3 hours. This puppy, even a basic made one, like, made at home garage shop, they can easily last 6 to 8 hours. And made by like professionals in like large billion-dollar budgets, they can make a one this have already achieved like around 80 hours to 1 month of flight time. So basically, you set it in the air and you don't have to think about it. It can keep collecting data. That is very precious, very important. So disaster relief efforts need this kind of technology. It's not like, oh, it would be nice to have. No, if we have this, it is a game-changing technology. Now, what we can expect in the future? Well, this is a tool. At the end of the day, it's a tool. Like, there are people who just have an angle grinder and a drill, and tada, they have a metal workshop. They built everything they did not have using just those two tools. And there are people who have those things and do nothing with it. So you can understand, it's just an aerial tool. How do you use it? That's up to you. For example, like, I live in India, and India has a very iffy border kind of situation. So basically, we have border with Pakistan, China, and a giant sea sector. So you can understand that patrolling this area is fundamentally impossible. Satellite, same impossibility. Basically, if you do low Earth satellite, you have to have hundreds and thousands of them just to give a proper coverage. And if you use geostationary, you lose angular resolution. What can you do? This puppy. These are cheap. These are affordable. These can be made in garage. So imagine this way. Let's say Indian Army is like, okay, we're gonna open a small division. No, like, multi-billion-dollar budget. It's like, small budget. Just get these things done, off-the-shelf parts, build this. What can be done? Awesome things. Think of this way. Let's say they make 4 of these and they're just flying in the Himalayan regions. It's just flying. Now, benefit of this would be, because it's flying so close to the surface, they can get much better photographs than any equipment possible on a satellite, and it is not consuming jet fuel, and it can remain in air indefinitely. Technically speaking, again, you would want to depending on your motor temperatures and all like that, you'll be like, hey, it can only remain in air, let's say, practically speaking, 1 week. You're like, okay, every week I have to land one. So you will design in such a way that you have a completely circular system where you can have a chain of this puppy scanning the whole area in much higher resolution. At that point, you're like, dude, this soldier crossed this plan. There is the wire line that you have to. There is the mine there. Like, that amount of resolution data is possible. Imagine sea area where you can literally spot every single area. And another aspect is radars work amazingly. There is no plane in existence or ever could be in existence that's like, okay, there is a radar, I can go through it. No, that's not happening. What modern stealth system does is like, okay, you can detect, let's say a good radar station can detect at 50 kilometer. I can get it to 40 kilometers and I still won't be there. That's the best they can do. Don't expect like the movie was like, oh, stealth aircraft, it can go YOLO. No, that's not happening. Now imagine you have a whole seacraft where you can't have a land-based radar station. You have hundreds of smaller ones. At that point in time, even the best stealth system is like, bro, you're coming from there. It's like, I can see you, man. Like, I can see that can happen. So it's fundamentally awesome tool. The moment any country realizes that how amazing this technology could be in terms of, and they don't have to like, oh, we are burning jet fuel. No problem, bro. No fuel. You don't have to worry. And these are small, light, cheap, efficient. So lot of potential there. If any government figures this out, whoa, I don't want to fight them. So lot of things there, and it can be done on low budget. That's the whole thing. There are German students who have built this puppy and they got endurance flights of 80 hours. Let that sink in. There is a flight that took 80 hours. That's awesome. That's flat out impossible to do without mid-air refueling. So let that sink in. And that was like, if you see the aircraft, it's not like, whoa, the most precise engineering ever done by man. It's like normal. So there is a lot of DIY potential, and I have provided a lot of video down below, and I would urge you to see them. So this was my presentation on basically solar aircraft. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me your disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you are free, and as always, thanks for watching.